Okay, so still there is one important concept that is going to be equivalence, number of equivalence relations. So before that we have to know what is an equivalence relation. Okay, so equivalence relation. Well, if okay, a relation has, if a relation is symmetric, okay, then if it is reflexive and if it is transitive, then it is known as an equivalence relation. Okay, so in order to find total number of equivalence relations or Bell number, it is also said as Bell number. Okay, we have to use this one concept, that is one formula. We have the one golden formula, so that is going to be B. So B KH is equal to summation of B N K C N, upper limit is K, lower limit is N is equal to C. Okay. Well, I know this does not make any sense to us. Okay. Wait. We will do one or two sums, then we will come to the conclusion whether it is easy or whether it is tough. Actually, here by using this formula, we can very easily find how many equivalence relations can be made by these many elements. For an example, a set is having, okay, a set is having 4 elements. Okay, a set is having 4 elements. Then how many equivalence relation can it make? Can it form? That's a question. Okay, so let's find out. Before that, you have to remember some values also. So these are golden values for this golden formula, that is B0, B1, B2. Okay, then also we can say B3. Okay, so B0 is equal to 1, B1 is equal to 1, B2 is equal to 2, B3 is equal to 5. Okay, now let us do one sum like B4. Okay, B4. Okay, well, this B is actually also known as Bell number. I'll write it a little bit good. B4, where 4 represents, it has totally 4 elements in it. Okay, now how are we going to do? You have to apply this formula. That formula is, it's going to be like this. First is B, you have to write. Okay, see, this is what the lower limit is. Always you have to start from the lower limit, then when we have to go to the upper limit. Okay, here the upper limit is K. Okay, in this formula it is K, but here the upper limit is, see, K is here, K is here also, right? So here also, this is what the K value is. So the upper limit is 4 and the lower limit is going to be 0. Okay, so B 0, then into K. Okay, not K, this is actually, we know this formula now. Which is n factorial divided by r factorial whole n minus r the whole factorial. Combinations, we have studied this formula. I hope this formula is correct, because 11th concept, yeah, this formula is correct. And for permutations, and the relation between this and this is that there should be one. If you want this to be equal, all you have to do is you have to divide this, not divide. Yeah, so you have to divide this by r. Then this and this will be, or you can multiply this with r factorial. So this and this will be cancelled, then you'll be getting this formula. Okay. Okay, so coming to here itself, which is b naught. Okay, so yeah, this is b0 actually. Okay, because here 0 is the lower limit, then kk is what, the upper limit. So 4, sorry, yeah, 4 into cn. N is what, here it is going to be 0 plus, like that you have to continue till, in place of 0 you have to put 4, like that you have to continue. So next is going to be what, b1 4c1 plus b2 4c2 plus b3 4c3 plus b4 4c4. Okay, all done, clear. Now also we are going to say a few things, that is NC0, NCN, then NC1. Yeah, for all these we are going to see now. Apply the Fourier formula, which is going to be n factorial by 0 factorial into n factorial minus 0. Okay, sorry, just n minus 0 the whole factorial. Yes, right. This will be cancelled, which will be 1. Okay, so it's 1. Now, and then if you just put it out, so it is also going to be n, which is nc0. We can also prove that. How will you prove that? N factorial by n factorial into n minus, yeah, n minus n the whole factorial, like that. Okay, which is going to be 0 factorial. So 0 factorial is equal to 1. So this and this you can cancel, which is also equal to 1. Okay, like this and this. Okay, so this is also equal to 1. Okay, so next is nc1, which is equal to n factorial whole divided by r, which is 1 into n minus 1 the whole factorial. Okay, correct. So how can you write this? This n factorial can be written as n into n minus 1 the whole factorial whole divided by n minus 1 the whole factorial. So this term and this term can be cancelled out, which is equal to n. Okay, so here also this is equal to n. Okay, so you have got n. These three are very important. Okay, now we are going to substitute their values over here. I will use different color. So what is B0? B0 is equal to 1, right? So 1 into, what is 4C0? Okay, what is 4C0? See, use this one. Okay, so 4C0 is equal to 1, because here n is equal to 4. Okay, so into 1. Okay, plus what is B1? B1 is equal to 1, right? So 1 into 4C1. That means what? You can use this formula, which is equal to into 4. Okay, this will erase. Then plus what is B1? B1 only, yeah, this we have completed. Next is B2. What is B2? B2 is 2 now. Okay, 2 into, what is 4C2? So, yeah, 4C2. That we will do here. So 4 factorial whole divided by 2 factorial into 4 minus 2 the whole factorial. Okay, so this can be written as 4 factorial by 2 factorial into 2 factorial. Yes, right. Now, how will you write this? 4 into 3 into 2 into 1 whole divided by 2 into 2. So this is equal to 6. Okay, so into 6. Okay, next is what? Oh, the board itself is shaking. Just now we complete this. Next is B3. So B3 is what? 5 plus with B3 even you have to complete, because B4 you don't know na. Yeah, with B3 itself you have to complete. Actually the thing is, how we have to write is B4 is there, right? So that this is actually, wait, I did not write, this is not actually H, that is plus 1, okay, K plus 1, here B4 is there, right, which is K plus 1, B4, here 4 is equal to K plus 1, so K is equal to 3, okay, so you have to write it like, it is equal to B of 3 plus 1, like that only you have to write, where 3 is what equal to K, so 3 is what the upper limit is. Sorry, it should be here plus 1, like this I wrote, okay, and instead of putting here plus, I put thing, okay. Now everything will be making sense to you all, okay. So plus last term here, okay, plus next is B3. What is B3? B3 is equal to 5, okay, 5 into 4C3. What is 4C3? This also we will write over here itself. Which is NCN minus 1. Is there, right? Which is equal to n factorial whole divided by n minus 1 the whole factorial into n minus 1 the whole factorial. Okay, so how can you write this? This n factorial can be written as n into n minus 1 the whole factorial whole divided by n minus 1 the whole factorial into, see, this minus will be multiplied inside, so it will be n minus n plus 1 the whole factorial, so which is going to be 1 factorial, which is equal to 1. Okay, this term alone we are talking about. So into 1 the whole factorial, you are just 1, so this and this can be cancelled, so at last it is going to be just 1. Okay, it is going to be just 1, which is equal to this, sorry, which is equal to this. Okay, but for our convenience we are going to prove this. Prove this in sense like 4C3 is equal to 4 factorial whole divided by 3 factorial into 4 minus 3 the whole factorial, which is equal to 4 into 3 the whole factorial, 3 factorial into 1 factorial, 3, then at last you have got 4. So sorry, it is not, so NCN minus 1 is equal to n, that you have to know. Okay, not 1, sorry I said it wrongly, NC, yeah, how you can also say like this, we have also another identity. Before that I will write this one, I will say that identity later, so it is going to be 4, which is equal to last 15. Yes, right, 1, okay, 15. That identity I said, right? In permutations and combinations class 11th we will be studying that. What is that? It is NCR is equal to NCR n minus R. Sorry. Correct, huh? Correct one. Like for an example, take this. 4C3 is equal to 4C4 minus 3, which is 4C1. Okay, so what is 4C1? 4C1 is equal to 4, and also 4C3 is also equal to 4. Okay, so yeah, now we are going to start about questions, but here it is 11 o'clock, but I don't care. So first sum itself is, there is a set, okay, A set is there, which is 1 comma 2 comma 3. Okay, I will try to make a different video for this sums. Okay, so now we will go with functions. Okay, so functions. Very important functions. Second phase we are entering. I don't know will I be able to make a video separately for sums, because according to me doing sums and explaining is kind of like wasting my time, as I'm also studying 12th, which is a very important year. I cannot waste my time, but explaining concepts is actually like beneficial for me and for you all. Unfortunately, I'm getting 200 views for my videos, which actually makes me happy. So what is a function? In function, first we will be giving you some basic introduction, then we will be going on. First is, oh my gosh, my head pains. Okay, so function is a special type. Is a special type of relation. Okay, and one important thing that you have to note is, now only my brain is working kind of properly, I think, is when we domain, okay, domain, an element from domain, okay, an element from domain can be marked only once. Not like that. Wait, I will explain to you by diagrams. Okay, by diagrams I will explain. I'll choose. Okay. So for an example, yeah, this is what X means domain, you have to keep it, Y means range, because every time writing domain is actually making me kind of lazy. Okay, so X means domain, Y means range, and then here what we are going to do is, we are going to keep it like, okay, so I'll write in blue color. Okay, A, B and C I have, and here I have 1, 2 and then 3 and 4 I have, where we have mapped A is 2, right. Okay, for A2 we have mapped, then for B4 we have mapped, then for C1 we have mapped. Okay, so is this a function or not? Actually, you have to see these two. First is, all the elements in domain must be mapped. Okay, then actually all these are set as free image and all these are set as image. Okay, free image and then image. Okay, so this is free image and then this is image. So this image, okay, like this it can be. Wait, once again. Like this it can be. But like this it cannot be. So an image can have two different pre-images. Images. Okay, so one best example is what? Which color? Is constant function. This constant function. Okay, next is, but another thing that you have to notice, a pre-image cannot have or can't have, in terms like you have to write small line and you can use can't. Okay, a pre-image can't have two images. Okay, like this is not allowed. Yeah, see, this is what a pre-image is. This one, no wait, yeah, a pre-image, this is what a pre-image is. This one pre-image cannot have two different images. Like this is not allowed. Okay, but this is allowed. Okay, so these are the essential points that you have to note. Okay, now function itself is actually classified into one, on to, then many one is all there. We will go to them slowly. Before that, we will cover some other topics also. Okay, see, that's okay. This is fine. Now we are going to see some cases which are not fine. Okay, which are not fine. All these I said, right? I hope all these are clear. Only these points only we are going to discuss one by one. First is point 1. A, B, C, D. 1, 2, 3. Like this it is mapped, like this it is mapped, like this it is mapped. See, this is being left out. Okay, so this is not a function. Like this, it cannot be. You have to know this. Okay. Next is you have like this, which is A, B, and then C you have, then 1, 2, 3, and 4 you have, but the mapping is alone like this. C is mapped to 1, okay, B is mapped to 4, and A is mapped to 2, and like 3. Okay, if you check, the red flag goes to here. Okay, the red flag goes to here. This is the place where the relationship is wrong, so you have to break up. Okay, there is no patching up, there is only break up in this case and in the previous case. Okay. So yeah, so these 3 points only you have to check whether is it a function or not. Like this you can check, and also we have a line test that also I'll be explaining very clearly. You need not to worry. Okay, so next is going to be, okay, one test is also there, that is what this line test is, which is vertical line test. Line test. Okay, so line test will be coming later, okay, because we have to also check on to, then horizontal line test will be also involved over there. So instead of discussing these two in different places, we will discuss them at one single place. But remember, there is also line test is there. Okay, line test. Line test. One second, I will just clarify which type of test is there. Vertical now. Okay. So here even we will discuss actually that also. Not a problem, not a problem, not a problem. By the way, 1111 was an angelic number. Was and is and will be an angelic number. Shapes. Okay. So I'm going to take two different functions. Clone, and here I will place it. Okay. So here I will place it. First, I'm going to take y square is equal to x. Okay. Secondly, I'm going to take y square plus x square is equal to 9. Okay. This is what I'm going to take. Shall we take also other two? Any other two? Also, wait. Okay, this is enough. First we will come with this, then we will go with this. Wait a second. All these are not functions. Whatever drawn is not function. Now, y is equal to x cube we will take. Y is equal to x cube is okay. So how will be the function then? Kind of very similar to the tan graph. Okay, like this only it will be. Oh, I'm so bad in drawing. Okay, so like this only it will be. Now, what you are going to do is you are going to do vertical line test in order to determine whether a diagram or whether a graph is a function or not. What you have to do is you have to do vertical line test. Okay, so vertical line test only you are going to do in order to determine whether one is function or not. Okay, so why vertical line test and what is this vertical line test? First is we are going to see what is this vertical line test, then we will be saying why vertical line test. Vertical line test is where you are going to draw one vertical line, okay, and if that one vertical line intersects only one point of that graph, okay, of that diagram of that function, then we will be saying that it is a function. Okay, so your function you have got passed as a function. Okay, but if in case for this diagram you take, what is that diagram? It is the diagram of a circle. Once again I will check here. It is diagram of a circle. So it's going to be like this. Okay, like this it is going to be. See, draw for this one vertical line. See, it is being intersected at two different points. Over here one and another one. You also draw here. Over here one and another point is also being intersected over there. So it is being intersected at two different points. For one line is being intersected at two different points, then this is not a function. Oops, sorry, not a function. Well, what you can do is, in this case, you can cut like this. Okay, actually cutting part is there where you will be restricting the domain, and then the not range will not be restricted, it depends. Okay, so you will be actually restricting the range. Thank God this is plastic. Okay, so here, why is this? Okay, why is this like this? Very simple. See, let's take that this is actually what, 2. Okay, so then this is going to be 8. Okay, then let's take that this is 1, then this is going to be actually 1 only. Okay, now see here, what is a function actually? I said very clearly okay, like this, if it is there, if something is like this, it is there. Then what is this? This is not a function, I said, right? Because like this diagram should never come. Okay, like diagram like this should never come, but diagram like this is accepted. Like Okay, 3, 27, like this is accepted, but like this it should never come. What is this? This is x, right? See, this is one x value and this is one x value. Okay, but this is one y value. Okay, for an example, see, this is what, this is the x. Okay, so you can say very easily this is what that x value is, and this is what the y value is. Yes, right? Oh. If you check here, what's there? Here x is actually same. Yeah. So here x is same. Here, no, like this it can be. Yeah, like this it can be. But like this only it should not be. Sorry. Yeah, I got confused. Like how it should not be? Like this only it should not be. So let me put here 1, here -1, here in place of here, what shall I put? We can put 3. Okay, we'll put 3. So then the diagram is like this. 1, 2, 3, -1, 1, -2, -3. Okay, like this only diagram is where x value is only 1. Okay, only 1 is the x value. But if you check y value, there is -1 as y value and +1 is also there is 1 y value. So that means what? Here is the x's which is fixed. Okay, which is fixed. That means only one x value is there. But coming to y value, here one y value is there and here one y value is there. And when you are marking for this one, okay, when you are marking for this one as in terms of this mapping diagram, where this diagram is wrong, like this it should not be. So that is why vertical line test we are considering, and when it is being intersected at two different points, we will be saying that it is not a function. Okay. Here you see, for 1 value only 1 is there. For 1, 1, 1, only 1, 1, 1 is there. That's it is there. More than that, it is not there, right? Okay. So vertical line test we have completed successfully. That's it. This is what vertical line test is. Let me this. This is total not required. Just for explaining, I said. Okay. So in this video, we have completed with basic introduction of of just functions. Okay. Next, we will be starting with types of functions. We will be going. I don't think it will be two different videos for you. I will edit it. Okay, I will cluster up all the videos together, and then I'll be posting around something like 4 hours to 5 hours. It will be taking. Okay, now it's time for me to sleep. Bye bye.